investigates how a capacitor charges and discharges. A capacitor is an electronic component that can store a certain amount of charge. It's here on the circuit. It has a value called its capacitance, measured in farads. This is an extremely large unit, and we only usually deal in microfarads or even picofarads. The capacitance is the amount of charge a capacitor can store per volt. It's per volt, as the voltage can be considered to be like a pressure. The higher the voltage, the more charge we can push into the capacitor. In the same way as we get more gas into a sealed container, the higher the pressure is. If you look at this circuit here, you can see that the voltmeter, which is the one on the left, is connected in parallel with the capacitor, so that gives us the voltage across the capacitor. So you see to the two wires here, and on the breadboard they're linked to the two sides of the capacitor. Whereas the multimeter on the right, which is set to measure amps, is in series with the capacitor. Okay, and this is in a series with a two-way switch allowing charge and discharge in connection to the power supply. Now, I think the book says it's done at 12 volts, but in fact the power supply is set at 6, which is just fine. You might like to zoom in a bit so you can see everything a bit more clearly. You want to get yourself set up quite nicely so you can see the meters and the power supply. And when you switch this on, which is indicated by this connector here, so when I switch that on you can see that it connects here. You change the polarity of this switch, it will start charging, and you really have to be quite quick off the mark to spot the original current and voltage. You may need to do this more than once to do that, and you need a stopwatch or use the Windows timer to take readings every 5 seconds. So it's going to immediately start charging, and the first readings happen very, very quickly. You'll need to be really on your guard to get those quickly, so we do this. And then you want to take them every 5 seconds. Voltage on the left, current on the right. And be careful to get the scale right, to get the units right for the ampage. You'll see in the book on the table how that's done. And so you can see that it's coming towards the voltage of 6. It kind of exponentially works its way up to there. So you do this for the length of time as specified in the book, and then eventually you're going to plot that, and it kind of levels off. So leave that for a while till it gets there, and then what you're going to do, I won't leave it for long enough here because it's just making the video longer for no purpose, but in the experiment you'll do it for a bit longer. And then when it's fully charged and it reaches close to 6 volts, switch off the power, and when you flip the switch the other way it's going to discharge. Again, you can see the circuits in the book, and again you want to time it every 5 seconds. You want to take the readings of the voltage and the current, and then you'll be able to plot the graphs and determine quite precisely how the capacitor charges and discharges. Okay, thank you.